Hello, everybody. I'm going to be going through 2018 FRQ number 6 on this Maclaurin series that they give. Um, Parts of this problem are going to be tested this year. So let's look at it and talk about it. The Maclaurin series for ln of x is given by this. There are some teachers that say this should be memorized, but I didn't require you to do that. On its interval of convergence, the series of ln of this guy is defined by this guy. So this is f, very important then. Here you understand that that is f. So the question is to write the four non-zero terms of a general term for the series of f. Don't forget this general term if ever asked for it. Sometimes some of you gloss over that. Trying to do this on a computer screen is a little bit more difficult. I would recommend you try to get through these problems crisply and quickly, and then go back and read them. There's only 2 FRQs you have to read, so make sure you didn't miss any parts, such as explain the meaning of, or find the general term like it is here. So this is basically telling you if you have this series for ln of 1 plus x, but it's not ln of 1 plus x, ln of 1 plus x over 3, the x over 3 is getting substituted for x. So every time you see an x here, you're going to be replacing it for x over 3. But this entire series is also being multiplied by another x. So then you're going to have to take that x and distribute it into each term. So I'm just going to do a couple of these to kind of analyze it. So this first red one that I drew was x. So now we're going to replace that with x over 3, step 1. So that's the substituting in for the x over 3 and for x. Then you also have to multiply it by x. Now you could have done all of this and just multiplied it by x if you wanted to, but sometimes, especially later on, it's going to make more sense. So x times x, if I could then distribute this in, is going to be x squared over 3. That's when you get your first term. And you're going to do that for all subsequent terms. Now, if all of these have one less factor of x, such as x to the first, x to the second, x to the third, x to the fourth, and then you left it like this with these parentheses and the x up front, they will give you that point. The general term, well, this is the general term again. So in place of this x right here, you're going to be substituting in x over 3. So you kind of are looking like this, x over 3 to the n. But then if you distributed this x in, like a lot of people do, then this x here is the n, but it actually is x to the n times an additional x, which gives you x to the n plus 1. Now, another way to do that is to write it like this. Everything else stays the same. -1 to the n plus 1, -1 to 1, and then your n on the bottom, your n on the bottom. But besides that, you just have to manipulate this x. So double check that. All 4 terms give you a point, plus the general term gives you another point. And just be wary of that. You can't let that x. Part B. On its interval of convergence, this series converges to ln of x plus 1. Let f be the function defined by this. Okay, so now this one asks you to determine the interval of convergence. Now, I don't think you're going to be asked in 2020 to find the interval of convergence, but you are going to be asked to do the ratio test to determine convergence. I'm almost positive of that. I'm going to be coming out with a little quick video once I've analyzed the 84 questions in AP Classroom of the type of questions you could be asked on series. So I'm going to go through all those 84 questions sometime in the next 2 weeks and then give you a video and try and come up with clarity. But ratio test is on. So you need to set up the ratio. Please, please, please do not forget the limit as n goes to infinity. And then this is a fraction, or flipping it over and doing a reciprocal. So this denominator here can be in back behind it and multiplied right there as long as you're doing the reciprocal. Perfectly acceptable. So then the second point is going to be, did you compute the limit of the ratio? The limit of the ratio is x over 3. So look on your paper. Do you have x over 3? If you do, you're good. How do you do all this stuff? Well, remember x to the n plus 1, and that will be on the bottom when you do the reciprocal, and x to the n plus 2. I'll just do one of these, so x to the n plus 2 is going to be over x to the n plus 1, and then you can subtract exponents when you divide, or you can think of canceling these ends if you want to, splitting them up if you want to. X squared over x to the first gives you just an x to the first. And then if you did all your n's, you're going to get to this. By n behavior models, where 1 is irrelevant, the limit as n goes to infinity is n over n, which means it's just basically 1. So limit of the ratio is right here. Radius of convergence is next. That's your third point. So the radius of convergence is going to be this. Now, when you do ratio tests on the 2020 exam, which you will have to do, you set this ratio, absolute value is less than 1. But this one asks for determined interval. So as long, I mean, you could, if you have this guy, x over 3, between 1 and negative 1, and then you multiply by 3, and you get x is less than 3 and greater than negative 3. That's the correct interval. You did the radius correctly. So this and this are essentially the same thing. So that's your third point. Now here's a little bit of my work with the multiplying by the reciprocal. There are some teachers that require you to memorize this, so they could have, as you go to these next couple points, this is just kind of like the memorized version of all that. I don't even think any of you have done all that, so you can kind of almost ignore this. But once you get that interval between negative 3 and 3, you do then have to go back and substitute in negative 3 over 3 to check the endpoints, because this is your interval, but you're not sure yet if it's, is it less than 3? Is it less than or equal to? Same thing on this side. Is it less than? Is it less than or equal to? I don't know. So how do you do that? You substitute in the endpoint 3 into the terms or the general term, and you analyze it. You can use part 1 and or part A and part B together. But this guy here is what happens when you substitute in 3. I'm sorry, negative 3. This is the negative 3 side, the left side. And then this is basically the harmonic series. So 1 over n is harmonic series, and you can just kind of think of it. So that's harmonic. So this side diverges. So this side is certainly going to be not equal to. If you, we'll go to this side here. X equals positive 3. So now let's just look at the points for a second. If you are doing something, what I'm doing here, and you did communicate that in your paper, you get this score. A lot of people forget that, so don't forget that. Now, how do you get the 5th point? You actually have to have these pieces correctly. So let's look at the other side. If you substitute in positive 3, this negative 1 is still there. So when you do this, you're going to be looking at this and saying, hey, that's the alternating series test converges. Or you could have said alternating harmonic. That's what it says also, and that converges. As long as you're looking for this word converge and you're looking for a test. If you have alternating series or alternating harmonic, and if you have diverges and harmonic, and you have this exact correct interval, that's how you get your 5th point. So you need like 3 pieces for that. You first of all need the correct answer. You second of all need the y's and the converge diverge part. Okay, that was a big long one. Those ratio tests are usually long ones. This last one, C. Let P4 of x be a 4th-degree Taylor polynomial. That's how this is signified as your 4th-degree Taylor polynomial. Means you go to the 4th. And on part A, you went to the 5th, so it's kind of like the same thing. This is your answer to part A for F. So now you're supposed to use alternating series error bound to find basically its error. How far is the polynomial off from the original function? So since you're using a 4th degree, you go to the 5th term right here. So then all you do is you substitute in your 2's, is what you're checking for. So 2 to the 5th, you could drop this because it is absolute value. You get 8 over 81. So first of all, point 1, did you use the 5th degree term? Point 2, did you have an answer? It said the upper bound, so you don't have to really do, is it within 1/1000th or something like that? You just have to actually have the upper boundary, which is the answer. It's a problem. They haven't done that a lot. Alternating series error bound will not be on this year's test for sure, but on this problem, part A kind of will be on there, and part B only using the ratio test of convergence will be on there. So, and just for those of you in the future, Lagrange, it's basically kind of like the same thing, but you're finding the maximum derivative. In this case, it would have been 15 instead of a third for all of these. If you want to remember Lagrange, but for those of you in 2020, this is not necessary, and so point C is not necessary. Thanks for listening today, and here was number 6.